All right. So yeah, the purpose of this video is to kind of take a look at um, uh, some uh, some things that numbers might have in common, and what happens when you combine certain numbers in a particular way. So let's start off by watching this little video here. So there's no audio to it, but yeah, let's give this a shot. Okay. Okay. Did we notice anything that happened there? Do we have any observations? Yeah, the sand fell. He flipped. Which one did he flip? The yellow one and the pink. Okay, cool. Any other observations? Yeah. Okay, so the yellow was flipped twice. The pink was flipped once. The yellow was only flipped once. Should we rewatch it? Let's see what's going on here. So it looks like it's speeding up there. So yeah, the pink was flipped once there. Yellow again. Okay. So the pink was flipped twice. Yellow was flipped once. Was the green flipped at all? No. No. Okay. So what does that tell us? Mm-hmm. The pink one is the smallest. Yeah. What do you mean by smallest? Yeah, it has the least amount of sand. What do we call these things? Yeah, we call them hourglasses. That's right. So these ones I don't think last an hour, right? Do you think that if we watch the video one more time, we'd be able to figure out how much time each of these represent? Yeah, let's try one more. Let's watch one more time and see if we can figure out what the timing is for each of these hourglasses. So he speeds it up. Okay, any thoughts? Yeah? Okay, so we're thinking that green, probably 5. What did we say pink was? 2. And then yellow was 3. Okay, okay. So let's take a look. I actually ended up writing it down somewhere. So there's the video itself. And okay, go away, keyboard. I don't need you. There it is. Okay. Yeah, so here we go. So here's our sort of our legend. So we've got 2, 3, and 5 minutes respectively. So each of these timers has about either 2, 3, or 5 minutes in them each. So the way the person was doing it was that as soon as the timer flipped, or sorry, as soon as the timer ended, they flipped it upside down, right? And they're going to keep doing that over and over again. So I'm wondering, I'm wondering when the first time that that person will flip all 3 at the same time. Do we have any thoughts about how long that'll be? Yeah, 30 minutes. Okay, and where did you get 30 minutes from? Least common factor. So are we sure those are factors? Okay, so they don't have any of the same common factors. So these don't have any common factors? No? Okay. So let's take a look. Let's see if we can get to the bottom of this. No, I don't want to give you feedback. Okay. Do you ever find like if an app bugs you about feedback, it like makes you want to give them bad feedback because like they annoy you? It's kind of silly. Okay. So we've got 3 timers, right? One of those timers is 2 minutes. The next one is 3 minutes, and then the last one is 5 minutes, right? So let's make sort of a timeline here. So this is going to be our timeline, and we're not quite sure how long it's going to go for. It looks as though one of us believes it'll be about 30 minutes. Okay, so we're going to go. Let's see how long this is going to take. So it looks like uh, uh, so every 2 minutes, right? Every 2 minutes, the first one is going to get flipped. So let's say that that's 2 minutes. That's 4 minutes, 6, 8, 10, 12, 14, 16, 18, etc. Right? So we'll keep going. We'll see how long this takes, right? So each of the little ticks on my screen is actually going to count as 2. Okay, so let's see how far this goes. 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42. Okay, so I've got 42 minutes there. So that's what would kind of happen over 42 minutes, right? Now let's do the 3-minute one. So we'll do that every 3 minutes. So that's going to be 3, and you can help me out here if you want. What's next? 6 then. 9, yep. Yep. Mm-hmm. Yep. And then 42. Okay. So let's go through here and let's circle all of the ones that they have in common. So they'll both get flipped at the 6-minute mark, right? They'll both get flipped at the 12-minute mark. They both get flipped at the 18. You can help me out here if you want. Yep. Mm-hmm. 42. So how many times, like if we did this like forever, would it ever stop? Would we ever come to an end? No. No. We'll always have multiples that are the same. So the numbers that I circled here, these numbers, these are called common multiples. Multiples of 2 and 3, right? So all of the numbers that I wrote in this list, like every single one of them, those are multiples of 2, right? These are multiples of 3. So the ones that I circled, those are common multiples of 2 and 3, right? And it should make sense sort of with its words, right? They're both multiples and they're common multiples because they're a multiple of both numbers. So let's do it for 5 really quick. 5 should be pretty quick. So the first one is 5, right? And that should actually be here, right? What's next? 10. Mm-hmm. 20's right here. Yep. 25. 30. 35. And 40. Okay, and we'll stop there. So let's circle the common multiples of 3 and 5. Okay? So 15 is one of them. Oopsies, that's my eraser. So I've got 15. What else? 30. Okay, anything else? Not on this list. But there would be more, right? What would the next one be? 45. Yeah. Yeah. Okay, so it looks like we actually have some common multiples among all 3, right? So this would be, maybe I'll use a different color actually. So how about purple? So it looks like 30 would be a common multiple among all 3 of those numbers, right? So just as you said, 30 at 30 minutes we would flip all 3 hourglasses. So at 30 minutes, not mins, come on, mins, all 3 hourglasses would be flipped. Okay, so all 3 of them would be flipped. So let's verify this. So I've got another video of this person flipping hourglasses, but it's in fast forward, so it shouldn't take too long. So let's watch this. Okay, so he's flipped a few of those timers. All right, so both the 2 and the 3 minute timer are flipped at the same time. So that's a common multiple of 2 and 3. Okay, then 2 and 5. 2 and 3 again. Then there's 3 and 5, 15 minutes. 2 and 3 again. 2 and 5. Okay, getting there. Things are starting to line up a little bit. Okay, 2 and 3 again. And here's the big reveal. Wait for it. And there it is. Okay, so all 3 hourglasses ended up at 30. Okay, so let's go back a little bit and let's see if we can get to the bottom of this mathematics. So it turns out that the least common multiple of 2, 3, and 5 is, well, the way we write this down, we write the LCM. Oops, too many triangles. There we go. The LCM of these 3 numbers, 2, 3, and 5, is equal to 30. Okay. So I wonder how we could calculate this. So I think you mentioned earlier that that one way to do this is to multiply all these numbers together, right? But I think that we know that there's going to be some exceptions, right? So in this case, it happens that 2 times 3 times 5 is equal to 30, right? Thing is, we don't always just multiply the numbers together to get the least common multiple, right? Certainly that will give us a common multiple of those 3 numbers, right? By definition, if you multiply 2 numbers together, then you'll get a common multiple of both of them, right? Because you'll be multiplying those numbers. But it wouldn't necessarily be the least common multiple, right? The least common multiple. So the least common multiple is the smallest number, which is a multiple of all of these. So let's try another exercise, and I'm going to give you a minute to think about this. So you can write this one down and see if you can get to the bottom of it. So what is the least common multiple of 4, 6, and 8? 4, 6, and 8. Any thoughts? How could we go about figuring this out? Go ahead. We got 24. Okay, so 24 would be, certainly that's a multiple of 4. It's a multiple of 6. It's a multiple of 8, certainly. How can we be sure that that's the smallest one? Mm-hmm. Okay, so if you were to divide 24 by some other number, like 2 or 3 or any of its other factors, then it's not going to be a multiple of one of the three numbers that we have, right? Is that what you're saying? Okay. So yeah. So this would be the smallest number, because if we were to divide it by some other number, like 2 or 3. Those are its only factors, by the way, just 2 and 3. I mean, it has 2 as a factor several times, right? If we wanted to think about it in terms of the prime climb, there's 2 as a factor of a total of 3 times. So 24, I can write 24 as 2 times 2 times 2 times 3. So if I were to divide it by one of its factors, like let's say if I divided it by 2, then all of a sudden this is no longer a multiple of 8, right? If I were to divide it by 3, if I took out one of those 3's, then all of a sudden I'm not a multiple of 6 anymore, right? So that's one way of thinking about it for sure. One of the methods that we can use to find the least common multiple when we're first learning about LCMs, and this is probably a method that you've seen before, is to do what we did over here with the number line. That's kind of the entry point to finding the LCM. We're going to want to step away from that before long, but this is kind of the first steps would be to write all three of our numbers, 4, 6, and 8, 4, 6, and 8, right? And just start writing all the multiples of 4, 6, and then 8. So here we've got 4, 8, 12, 16, 20, 24, 28, 32, etc. Then we'd have 6, 12, 18, 24, 30, 36, etc. 8, we would have 8, 16, 24, 32, etc. So going through this list, we can just look immediately and say, okay, well, 24 is the first number. 24 is the first number on all three lists. Okay, so that would be one way to find the least common multiple, right? Because certainly, like 8 is on this list as well, right? So 8 is a common factor of 4 and 8, but 8 is not on this list, right? Same with 16. So 16 is on both of these lists, but it's not on the list of multiples of 6. So the first one that appears in all three lists, that would be the least common multiple. Now, if I were to give you some larger numbers, then we're not going to want to be making a list, right? Some of these lists would have to be like 20 or 30 or 40 numbers long. And if they're already big numbers, then you're going to have a bad time, okay? So what we're going to do today is we're going to look at ways that we can use some of the methods that we learned about yesterday, which is writing numbers as a prime factorization or a prime power decomposition. So we're going to be using that information to find the least common multiple, okay? So I'm going to end the video here, but I'm going to still obviously stay with you guys. But I'm going to show you some methods for finding the least common multiple using prime factors, okay? So there's the end of the video. Okay.